Hello students, welcome to lecture 3. Today we will cover slope calculations. So there's really only one key formula. G equals to V over H. G stands for gradient. V, as shown by the red line in the section below, stands for vertical or elevation change, aka rise. H, as shown by the green line in the section below, stands for horizontal distance, aka run. But gradient is usually a very small number. If we have flat parking lot in our daily life, it can have a gradient of, for instance, 0.02. So to ease communication, we multiply gradient by 100, and then we get S, which stands for slope percentage. It is slope expressed in percentage. So in the same case of a parking lot, you can say this parking lot is at a slope of 2%, 5%. Then that's a lot easier than using a gradient of a small number. And to help you with your exercise 3 that is assigned today, we have a small handout with this key formula on it. It is also available on Canvas. You could print it out and even tape it to your table while getting familiar with the calculations.
So how exactly do we calculate slopes using G equals to V over H? Now remember that H must be measured on the plan. It is not the blue line in the section below that measures the distance on the ground between the 2 points. It is the green line that must be measured on the plan that represents the horizontal distance between the 2 points. V, the vertical or elevation change, must be calculated using spot elevations. We basically need to find out the elevations of the 2 points and then calculate their difference, right? G is not the same as S. Remember, in the formula, S, the slope percentage, equals to G multiplied by 100. Neither G nor S represent the angle in degrees. It is very important to remember that we do not represent slopes in angles in this class. For instance, we can't say that, oh, the slope in the section below is about 30 degrees. That expression does not help contractors to measure slopes and to build slopes correctly. Instead, we represent slopes in either gradient percentages or ratios in this class. I will explain what ratios mean in a few minutes. So, in order to calculate slope, we must have 2 of the 3 variables. Sometimes you know 2, sometimes you know only 1 and have to set a trial for the other. Next, we'll use examples to explain what that means.
So first, we have the easiest case where we have 2 spot elevations at both the top and the bottom of the slope. And all we need to do is to find out the slope percentage. And here, we can use the direct form of this formula. Slope percentage equals to gradient multiplied by 100, and gradient equals to V over H. But what if you already know the slope? Instead, you need to find out the elevation at a specific point. So we need to solve for other variables by transforming the basic formula of G equals to V over H. Right? In this case, what we need to find out is V, and we transform the formula so that we know V equals to G multiplied by H. So now we can use this transformed formula of V equals to G multiplied by H to find out an unknown spot elevation under the condition that we already know one of the spot elevations, the horizontal distance, and the slope. So that's the second formula we have on this handout. V equals to G multiplied by H. Now remember, G equals to slope divided by 100. What if we need to know H instead? Now remember, we had formulas for G and V in our previous slide, right? So in order to know H, we transform the formula again to get to H equals to V divided by G.
So here is an example of where we would use this formula H equals to V over G. So in this case, we know one of the spot elevations, we know the slope, and we need to find out where the next whole numbered contour is located on the plan. Essentially, we know the elevation difference, V, between the known spot and the next whole numbered contour. We know the slope. Then we calculate the H based on V over G, and then on the plan, we measure that H out and know exactly where this whole numbered contour should be located on the plan. So that becomes our third formula on the handout. H equals to V over G. Again, do not forget that G equals to S divided by 100, if S is the one that's given to you. We need to remember that slopes are proportional. So think in terms of units to get the conceptual idea about slopes. In the example below, suppose we have a horizontal distance of 100 feet and a vertical change of 4 feet. What's the slope? The slope percentage would be 4%, right? So the vertical distance is a proportion of the horizontal distance, in this case, 4% of that. So now if you're given a different horizontal distance, for instance, a 50 feet horizontal distance, should be very quickly calculating that the rise, the V, the elevation change here would be 4% of the 50 feet as well, which is 2 feet. The same thing, if the horizontal distance is 25 feet, the rise would be 1 foot. It is a very important skill over the course of the semester to be able to visualize the common slope percentages in your head in the form of these triangles. What does that mean? So suppose we are talking about contour drawings with a contour interval of 1 foot, meaning the vertical distances between different contours is 1 foot. Okay, so if the contour spacing, the horizontal spacing is 100 feet, what's the slope represented here? Now remember, slopes are proportional, so over the next couple weeks, we should be really quickly able to calculate out the slope here is 1%. What about a contour spacing of 50 feet? Again, proportional, remember, 2%. 25 feet, 4% slope. 12.5 feet apart, that represents 8%. Now, if I ask the question in a different way, Suppose that we're designing a 1% or 2% or 4% or 8% slope for a certain surface. How far apart should the contours be? Right? So now, instead of asking for S, we're asking for H. Now, again, over the course of the semester, you should be able to very quickly, in a minute, know the horizontal spacing for 1% slope would be 100 feet, for 2%, 50 feet, 4%, 25, 8%, 12.5 feet apart contours. With this slide, I hope to explain slopes expressed as ratios. Here, the ratio refers to the ratio between the rise and the run, or the ratio between the vertical change and the horizontal difference. Either way to write the ratio is fine. So you can see from the slide here, I have for the upper triangle 1 to 8 or 8 to 1 slope. Different countries use a different format here. So this is a difference between United States versus the Europe. And we know that a 1 to 8 slope is equivalent to a 12.5% slope. Similarly, a 1 to 5 or 5 to 1 slope is equivalent to a 20% slope. That'll be all for Lecture 3, Slope Calculations. Thank you and see you in class.